Okay, so let's go ahead and get started. 4.1, let's go to 4.1. We are on page, where are we at? We are on page 216, page 216. Congruence and transformations. So transformations, you actually did. You've done these in pre-algebra, and you've done, some of you might have even done in mid-high math too. I don't remember if you guys did it in there or not. But we did transformations, so you guys know how to do these things, okay? So translation, then you have the reflection, rotations, and dilations, right? So there are different things here, okay? And you've like I said, all this stuff you've already done before. So it's kind of, let's kind of work our way through here. So example number one, we'll do example number one. Example 1A says, apply the transformation to the polygon and with the given vertices. Identify and describe the transformation. So M is, so the transformation is where you had X and Y, they want you to transform that into X plus 2 and Y minus 5, okay? And they give you the three vertices here. So you get P is 1, 2, Q is 4, 4. And then you have R is 4, 2. So making the transformation is pretty simple. Okay. And the only thing that I kind of want to point out here is that when we do the transformation is that if I transform P and I move it, we call the new point P prime, okay, P dash, right, okay? So we're gonna have 1, and we put 1 plus 2, so it's gonna be 3. 2, 2 minus 5 is negative 3. So this is simple. Q prime, 4, I put 4 in here, I get 6. I put 4 in here for Y, I get 4 minus 5, which is negative 1. And then I have R prime, which is 4. If I put 4 in here, I get 6. I put 2 in here, I get negative 3. Okay, so basically I had something that looks like this. So let's see if I can draw this. Okay, so I had 1, 2, 1, 2, call that P. Q was 1, that's 4. That's about there. Then I have R, which is 4, 2, which is right here. Looks like I had a triangle that looks like this, where this is P, Q, and R. Okay. When I did the transformation, I had P as 3 and negative 3 now, right? So I have 3 and negative 3, which is down here. Q is 6 and negative 1, so this is P prime. Okay. Q prime is 6 and negative 1, so this would be Q prime. R prime is 6 and negative 3, so it's 6 and negative 3. R prime. Okay, so basically I took a triangle that was here and moved it over 2 and dropped it 5, right? And you can see that, right? So am I adding 2? So I moved it 2 to the right. And I'm subtracting 5, so I'm dropping it down 5, right? So that's basically what happened. I took this and I moved this down. This we call a translation, right? It's a translation because I didn't reflect or rotate it. I just kind of moved it down here, right? I just moved it down here, okay? All right, that's called a translation, okay? So if you go to the middle of page 217, there's a little box there that says representing transformations in the coordinate plane. First one is translation. So we did a translation, right? X, Y, and then you X plus A and Y plus B. So A here would be 2, B here would be negative 5, okay? All right. So that was a translation. So that was A, that was good. So let's see if we can do the next one. B, we have, the translation is I start with X, Y, and I'm going to move it to negative x and y. I have A is 1, 1, B is 3, 2, C is 3, 5. So now let's do the translation, right? So the new point is going to be A prime. And I have wherever I've got where x is, I put it to minus x. So I'm going to go wherever, since it was 1, it's 1. Now it's negative 1. Y stays the same as 1. B prime 3. So it's going to be negative 3. Y stays the same as 2. C prime 3 here at x. I'm negative x. So it's going to be negative 3 and 5. Okay. So let's go ahead and draw this out, see what we get. A is 1, 1, so we'll call this A. B is 3, 2, so 3, 2, this would be B. C is 3, 5, so 3, 5. It's going to be up here, this is C. Okay, so I'm going to have a triangle that looks like this. Okay, so let's go ahead and plot the new transformation. After the transformation, A prime is negative 1 and 1. So it's be negative 1 and 1. So this guy is A prime. B prime is negative 3 and 2. Negative 3 and 2. So this will be B prime. C prime is negative 3 and 5. So negative 3 and 5. So this will be C prime. So if I connect the dots together, you're going to get a triangle that looks like this. So basically what happened is what? I took this triangle and I flipped it over. So I flipped it over like that. So it's a reflection across the y-axis, okay? All right. So this is something that's kind of important for those of you who are going to go into honors pre-calc and calculus, okay? When we flip it across the y-axis, wherever x is, I'm going to put a minus x. Okay. Also, it kind of makes sense if you think about it. If I'm going to flip it across the x-axis, and if I want to flip it across the x-axis, where y is, I will put minus y. Okay. And that is on the reflection on the second one, page 217 in the box, reflection. It shows you the reflection across the y-axis and reflection across the x-axis, okay? That's kind of interesting, okay? So that's that. Let's move on to the next one. So I'm going to C. Okay, from here, we are going to do M. This is a little bit not as intuitive, okay? X, Y, and I'm going to go ahead and transfer to minus Y and X. I'm going to start with the 3 points or 4 points. R, E, R, E, C, T. R is 1, 2, 1, 4, C is 5, 4, then I have 5, 2. Let's go into the transformation. So the transformation after R is going to be R prime. So this is X and Y. I'm going to put minus Y in front. So I had Y was equal to 2 here. So it's going to, front is going to be minus 2. X, I move the X over to the Y now, and that's going to be 1. E prime. So again, Y is 4 here. So I'm going to get negative 4. And that's just straight over. C prime is going to be X, Y is 4, so it's going to be negative 4 over here, 5 over here. T prime is, so 2y is 2, so I'm going to negative what? So negative 2 and 5. Okay? So if we go ahead and do the transformation, if we go ahead and plot it out, I have 1, 2, that's R. I have 1, 4. That's E. Then a C is 5, 4, C. Then I'm going to have 5, 2 is T. So now I see why they use RECT, because it spells rectangular, because this is a rectangular shape. Okay. R prime is -2 and 1, so -2 and 1. This would be R prime. And then we have E prime, which is -4 and 1, -4 and 1. So that would be here. That would be E prime. C prime is -4 and 5, -4 and 5. So that would be up here. So that would be C prime. And then I'm going to have T prime, which is -2 and 5. This would be T prime. Looks like that. Okay? So if you look at it, what I did was I took actually a rectangle that looked like this, and I rotated over and put it like that. So it's a rotation here, okay? All right, so that's a rotation. Okay, so if you look at the rotation on table 217, there are 3 of them. Okay. Now the point is that I do not want you to memorize these things, okay? Don't memorize those little boxes there, okay? You need to understand what's happening, okay? So the translation is easy. Reflection is kind of, we talked about, so that's not too hard. I would not, have you guys memorize the rotation stuff. So I wouldn't worry too much about that, okay? But you can see that as you plot it, you can see how this rectangle that was sitting this way got rotated over here, okay? All right, that's the important part for you to be able to recognize what had happened, okay? Not necessarily looking at the mathematical transformation and say, oh, I know exactly what that's going to be before it even happens, okay? So in D, we have the transformation is, what is the transformation is? X, Y, I'm going to go ahead and make that to 2X, 2Y. Okay, now this is the first one where on the X's and Y, you're actually multiplying or dividing it, okay? So that's kind of notable here, all right? Let's see, we have KLN, where K is -1 and 2, L is 2 and 2, N is 1 and 3. Okay, let's do the transformation. So K prime, so I'm doing is multiplying both sides by 2, right? L prime, 4, 4. N prime is 2 and 6, right? 2 times 1 is 2, 2 times 3 is 6. Okay, let's go ahead and plot this. We're going to start with -1 and 2. So this is K. And then I have 2 and 2. So this is L. And then I have 1 and 3. So that's N. So this is where I started, okay? K prime is -2 and 4, -2 and 4. L prime is 4 and 4, so it's gonna be about 4 and 4, so it's gonna be L prime. This was K prime. N prime is 2 and 6, 2 and 6. Okay, so we started with a smaller triangle and then we got bigger, right? So this is like what? You took it to a copier and you exploded it, right? You made it large, enlarged it, right? Enlarged it, right? So this would be a dilation, right? Because actually you have actually changed the dimensions of the object itself, right? And that is, again, we could have guessed that because we're actually multiplying these things by 2, right? You're multiplying it, right? Whereas in the other ones before, we didn't do any multiplication. We added and subtracted, we changed the signs and that kind of stuff, but we never actually multiplied it. So this is the first time we're doing that. And as you can see, we took a smaller triangle and we blew it up and enlarged it, right? Okay. So that's that. On the bottom of page 217, transformations and congruence says that translation, reflections, and rotations produce images that are congruent to their pre-images. So again, the shape itself did not change, okay? You have the same congruent end result with what you started with, okay? And it says dilations with a scale factor that K produce images that are not congruent to their pre-images, like this, right? We blew it up by 2, okay? So it's going to be different. I mean, it's going to be larger. It's not congruent. They're similar, but not congruent, right? Okay. Flip the page. Let's go to example number 2. Okay, so example number 2, we have what? Determining whether figures are congruent or not. Okay, now they're just going to give you 2 sets of points and you have to draw it and then see if the figures are congruent. So this is pretty simple, right? So A, we have ABC, I have ABC, and then I have PQR, and I have the coordinates are 1, 1, 4, 1, 4, 3. And then here I have -4, 2. Q is -1, 2. R is -1, 4. Okay, so let's take a look. Let's go ahead and draw this out. Okay, what do I have? I have A is 1, 1. This is A. And then I have B is 4, 1. C is 4, 3. So this is my first figure. Okay. Then I have PQR. P is -4, 2, -4, 2. That is P. We have Q is -1, 2, -1, 2. That's Q. R is -1, 4. Okay, they look like the same shape, right? And actually, after you've drawn it out, you can go ahead and kind of measure these, right? A to B is, this is going to be 3, right? Because it goes from 1 to 4. This stays the same. It's going to be, this length is 3. PQ is this point and this point. Again, the Y's are the same, -1 to -4. So it's going to be 3 different. So this is 3. This is 3. So I know that this guy and this guy are the same. Okay. Then I have C and B, right? So -4 are the same. I go 1 to 3. So this must be 2, right? C and B is this, so this is 2. Over here, I have Q and R. If I look at Q and R, I have X is -1. I go from 2 to 4. This again is going to be 2. In other words, so this guy and this guy are the same. If you do the next one, it's going to be the same also. Okay. And actually, if you graph this on a grid paper, okay, you should be able to count the squares and find out they're the same. Okay. Or you can say that they're congruent. Okay. And B, I'm not actually going to go over B. I would go ahead and just read it. Again, you're doing the same thing. You're plotting it and seeing if whether or not the two things, the two shapes are congruent in the end. Okay. So let's go ahead and move on to example number 3. Example number 3. what do we have? We have prove that the polygons with the given vertices are congruent. Okay, same thing. All you're going to do is go ahead and plot them out. So I have A, B, C. I have P, Q, R again. A, B, C. A is 3, 1, 2, negative 1, 7, negative 1. Q is, no, P is negative 3, negative 2. Q is negative 5, negative 1. R is negative 5, negative 6. Okay, let's go and draw it out. Okay, A is 3 and 1. B is 2 and negative 1. So this is A, this is B. C is 7 and negative 1, 7 and negative 1. So this would be C. I have a triangle here. P is 3, negative 3, negative 2, negative 3, negative 2. So that's P. Q is negative 5, negative 1. So negative 5, negative 1. This would be Q. R is negative 5, negative 6. So if we go down here. Okay. So what happened here? Looks like we did a rotation, right? We rotated this over to look like that. So it's a rotation here, okay? Again, you can go and if you put this on a graph grid, okay, you should be able to see it, count the squares and see that all the sides are the same. And as you know, even though we haven't talked about this, but we'll talk about this pretty soon. If you have 3 sides, right, the triangles are going to be the same, right? Because if I gave you 3 lengths of sticks, right, there's only one triangle that comes out of it, right? They're all the same, right? So as long as the 3 sides are all the same, it's the same triangle. It's a congruent. They're both congruent, okay? All right. Example number 4. Let's look at example number 4. What transformation is used to create the freeze pattern in this cast iron gate? Are sections of the gate congruent? Explain your answer. Okay, so the repeated horizontal translations create the freeze pattern translation of any section either to the left or right by a distance equal to the, so yeah. So they're congruent, they have to be the same, right? Because it looks like if you look at the red boxes look approximately the same. And they're just carbon copying it, just, copying it one by one. So it must be congruent. Okay? All right, so that's it. So that was 4.1.